Hello, welcome with Blue today as we continue our journey. There it is. We're looking at creating and evaluating functions. That's the topic for the day. Let's get that away. Here we go. So function, and we've talked about function notation, so we remember this is the C of A is equal to T, okay, and the B of F is equal to A. Those are the sort of functions that we're talking about. So this is some sort of numerical value. This is usually a numerical value, or it could be an expression. But anyway, on with the show. So to evaluate functions, we have an input. We put into some sort of machine or some sort of mathematical process, and we get an output. Sort of like when you're making, put ingredients into the oven, and you get cookies out or whatever you're making. So let's just say the function here was multiplied by 2. If I put a 3 in, what comes out? 6. If I put an 8 in, what comes out? Times 2, 16. That sort of thing. That's how a function works. We have just successfully evaluated our first function. Now, we're going to write functions in this function notation. Remember, this means the f of x. That's how we say it doesn't mean f times x, even though sometimes of means times. But we read this as the f of x is equal to 3x plus 4. Okay? And so if we want to know what the f of 3 is, well, that just means take 3, put it where x is. So it's 3 times 3 plus 4, which I think is 13. If we want to know what the f of 7 is, well, we take 7 and we put it where x was. 3 times 7 plus 4, and we're just, 21, 25. So this is that order of operations stuff. This is why we practiced with that at the very beginning, just to make sure that we're good with it. And then 3 times negative 4 plus 4. If we want to know what the f of negative 4 is, 3 times negative 4 is negative 12. I'll go another step here. Negative 12 plus 4. It's like negative 12 plus 4, I think, is negative 8. 12 minus 4 is 8. Bigger number is negative, so we keep that sign. All right? So that's how that works. And if we had a problem like the g of x is equal to x squared minus 4, well, then we'd, if we want to know what the g of 5 is, 5 squared minus 4. Remember what 5 squared is? 5 times 5, 21 minus 5, or 25 minus 4 is 21. Got ahead of myself. If we have to square negative 2, now this is a little tricky part, because if we're squaring negative 2, we need to remember that this is negative 2 times negative 2, and a negative times a negative is a positive, and so we get 4 minus 4, which is 0. Okay, you need the parentheses just to remind yourself that you're squaring a negative number. You need the parentheses so your calculator knows you're squaring a negative number. If on your calculator you do negative 2 squared, the calculator knows order of operations. It'll square the 2 and make it 4, and it'll give you negative 4, which is not the answer we're looking for, so don't do that. Okay? The g of 11, we're going to take 11, we're going to square it, we're going to subtract 4. We're going to get 121 minus 4, which is 117, okay? If we take, can't do it, if we want to know the g of gorilla, I got to go back to this screen because I need my little pointer. The g of gorilla is going to be, oh, come on now, I worked so hard on this, and now it's not going to work. It's going to be gorilla squared minus 4. Whatever's in the parentheses, that's what we put into the function. So if it's a gorilla, we put a gorilla in there. Gorilla squared minus 4. That's all we're looking for. Let's make it a bigger gorilla. Okay, so gorilla squared minus 4. I don't know what that equals because it's a gorilla. But you get the idea. Back to full screen. Ooh, it's even bigger now. So just take whatever's in the parentheses, put it into the function, do the math. Sometimes we're going to have a little story, and we're going to have to create a function to answer some sort of a question. So it's Yogi's birthday. Boo Boo gives him 5 picnic baskets to celebrate the special day. Every day after that, Yogi borrows 3 picnic baskets from unsuspecting campers. How many picnic baskets will Yogi have after 10 days? That's the question. And so, I'll try to cough that out of there. So that was a cough. We'll get rid of it because otherwise your ears will just explode. Every day after that, Yogi borrows 3 picnic baskets from unsuspecting campers. So we're trying to come up with some sort of function, and probably it would be the function of picnic baskets as a function of the number of days it's been. And so we might come up with a rule that says we start with 5 picnic baskets, and every day we add 3 more. And so if we want to know how many picnic baskets we have after 10 days, we would just do 5 plus 3 times 10, which would be 35. So 35 picnic baskets. Oops, I have to do this again. I need to be able to get my pointer. Oh, bye-bye, Yogi. All right. I don't know if that was worth it, but back there. Pen. I need to be able to get a pen and a pointer faster. All right, talking to myself. So there we are. That was Yogi's birthday, the little Yogi's birthday special map. All right, so what about this gym membership? So we've got 2 plans. We can pay per visit. If we pay per visit, we've just got to put $12 down, and then every time we show up, we give them $3, and we can come to the gym as often as we like. Or we can get the unlimited plan, which means we pay $65 a month up front, and that's it. We just show up whenever we want to. So which plan is going to be the best one? And how are you going to decide which one is the best one? Probably we'd do some math. Maybe we'd make some sort of a function, right? So if we look at this first one, the cost as a function of the number of visits, cost as a function of the number of visits, is going to be 12 plus $3 a visit. Okay, that's for plan per visit. And the other plan, which we're going to just call U of V, is equal to 65. And so we could figure out, by either graphs, tables, charts, or something along those lines, when it would make more sense to pick one versus the other. I would presume that, if your number of visits is going to cost you more than $65, that's when you'd make the switch, right? I don't know whether that's 10 visits, and see if we just, we can sort of do a guess and check, or we can be sophisticated. Let's just go with, we could try to solve this equation, which I'm sure you all know how to do. If we solve that equation, we'll get a number. We can do some guessing and checking. 10 is going to be too little. 3 times 10 is 30, plus 12 is 42. 20 is going to be too much. 60, 72. So it's someplace around 20. If you want to solve this and get me the exact number, that's okay. But the idea is we ought to be able to take information and try to figure out some sort of an equation, some sort of a plan to get us there. Is that right? All right, and then here's a little data that I made up, but maybe I didn't. How many police officers are there in a city with 20,000 people? Here's the data. These are tens of thousands of people. Well, that doesn't make any sense. This wants to be 200,000 people. Good Lord, because 20,000, I already gave you the answer, didn't I? So if it's 200,000 people, that's what we wanted to say. How many police officers in a city with 200,000 people? Here's some data. If they've got 10,000 people, 2. 20,000 people, 3. 30,000 people, 7 police officers. 40,000 people, 15. And 50,000 people, 30. So we're looking, and we can see that there's not really a clear jump. +1, +4, +8. Oh, well, we've got some sort of almost doubling sort of thing going on, right? So let's just sort of come up with an approximate. We know it doesn't appear to be linear, so let's see if it's some sort of exponential. And so we'll do 3 divided by 2, okay, to figure out the rate here. 3 over 2. We'll do 7 over 3. We'll do 15 over 7. And we'll do 30 over 15. And we'll use those 4 rates to sort of get an average rate of change. If that makes any sense? We'll take the average of the averages and call it an average. It's not really all that great, but we'll see what we can come up with. So I'm doing this on the side. I should get out that calculator and do that. Okay? I'll be back in just a brief moment with the calculator on the. All right, so here's the calculator that we can use. It's just the basic graphing calculator that we always use, and I make it really, really big so it covers the screen. We'll see what happens there, but I can't see my numbers anymore. Oh, for the love of Moses. Numbers 3/2, 7/3. So 3/2 plus 7/3 plus 15/7 plus the last one was 30 divided by 15, which is 2. Enter. So I get 7.97. And I'm just going to, we're 4 numbers, so I'm just going to divide by 4, 1.99. So pretty darn close to a rate of change of 2 as we work our way through there. So pretty close to 2. Let's put that down there. So my rate of change, bend back, rate of change we're going to say is approximately 2. We'll be real specific and say 1.99. So if you remember, we'd write an equation, a function, and this one's going to be the number of police officers as a function of population. And we want to know the capital P of 20, okay, which would be like 200,000 police officers, okay? So our function, it's going to be an exponential sort of equation, 2 times 1.99 to the x power. And so if we go to the calculator, we're going to do 2 times 1.99 to the 20th power. And so let's go back to the calculator. Where is it? There it is. Okay, and let's do 2 times 1.99 raised to the 20th. Let's see what we get. That's a lot of police officers. So our model may not be so great, right? 1,897,000. So that means we've got more police officers than we have actual citizens. 1.8 million police officers. So our model's not so great. And if you think about it, there's probably a point where our model doesn't become effective anymore because there's a certain point where you got enough police officers to do the job. You don't need a billion police officers in a city of 200,000. But anyway, that's how we'd make it work. So we can create functions based on data. Sometimes they work, sometimes they don't. They'll help us to solve problems and answer questions and figure out how many picnic baskets Yogi would get. And that's about all we've got for today. Remember, g of monkey is monkey squared minus 4. So store that away. Hey, thanks for watching. I hope you learned something. Hope you paid attention. If you have questions, please ask. We'll practice with these sorts of things and keep moving forward. Thanks again.